So we're continuing with the related rates problems, and you're probably going to see a lot of ladder problems. So we have a 25-foot ladder leaning against the side of a house. So here's your 25-foot ladder. It's leaning up against the side of a house. Nice thing about houses is they make a right angle with the ground. So we're pulling the base of the ladder away from the wall. So let's call this side X. Now here's where you have to be a good critical thinker. The ladder never changes sizes. That 25 foot is always 25 foot. In other words, this is a constant. And this side length will change, so we could call that dx dt. And this side length, we'll call this y, by the way, can change. We'll call that dy dt. But the length of the ladder is always 25 feet. So how fast is the top of the ladder moving down the wall when the base of the ladder is 7 feet from the wall? Okay, well, let's create a Pythagorean theorem here. So x squared plus y squared equals 25 squared. And if you have your Pythagorean triples memorized, it'll help you tremendously. If this is 7 feet away, a Pythagorean triple is 7, 24, 25. If you don't believe me, pause the video and double check that that does work. 7 squared plus 24 squared does in fact equal 25 squared. And in the premise of the problem, they also told you it's being pulled away from the wall at 2 feet per second. Now, here's where some students get confused, is whether or not the rate is positive or negative is if the value is getting larger or not. So if I'm pulling away from that wall, 7 will get larger. So that makes sense that this value is positive. So with that same logic, if the height from the wall is going down, you better get a negative answer because y will be getting smaller. So now we can actually do the problem. 2x dx dt plus 2y dy dt. And please don't forget that 25 squared is a constant, so that derivative is 0. Another thing I would do, if you want my opinion, is I would go ahead and divide everything by 2. That way you have less algebra to do. So we know that when x is 7, y is 24. We know dx dt is 2. And we're going to solve for dy dt. So now this is easy math. You can just subtract 14 over and divide by 24. So dy dt will equal negative 14 over 24. And that could reduce as negative 7 over 12. And again, some teachers make a big fuss over it. I'll just let you know what the units are. Is feet per second. And that should make sense if you think about the only rate we have. And if you measured it out, x is measured in feet. This is in feet per second. So we're at feet squared per second subtracted over and then divide by the number of feet. They would cancel out and you're back to feet per second. So now what they're asking you to do is to find the rate at which the area of the triangle is changing. So I guess what would be important to realize is that we now need this is dy dt to answer this question, because area of a triangle, let me switch colors, is equal to 1/2 the base times height. Well, the base that I used was x and the height I used was y. So if I ask you for the rate at which the area of the triangle is changing, then go ahead and do dA dt is equal to, we have the power rule. Take the derivative of x, leave y alone, plus leave x alone times the derivative of y. So now you can go to the calculator, or if you're good with the arithmetic, that dx dt was 2, y was equal to 24, x was equal to 7, and dy dt we found out was negative 7/12. So 1/2 times 2 would cancel, So we have 24 minus 49/24. Hopefully I'm doing the math right in my head. Minus 7 times 7 would be 49. I didn't hit minus, so change that to negative. I already forgot what I said it was going to be. 24ths, yeah. So 527/24. So what does that mean? Again, areas in square units, so it would be feet squared per second for your answer in units. So this means that the area would be increasing, and I don't know what that is. It's a decimal. I can change it to a decimal. Math, decimal. So it's increasing at a rate of almost 22 feet squared per second. And then find the angle formed by the ladder and the wall of the house is changing when the base is 9 feet. Oh my goodness, they changed the numbers around on me. Okay, so what angle is made with the house? The wall, the ladder, and the wall of the house. So we're talking about this angle up here. And they changed this to be 9 feet now. Now this is still a constant of 25. So as we're pulling, I guess we're still pulling it at, so dx dt is still going to be 2 because they haven't changed that part of the problem. So as I'm looking at this as a right triangle, to identify that it's opposite over hypotenuse, so it's sine of theta equals 9/25. So what's the derivative of both sides? That would be cosine. I guess I need to be careful. Let me leave that for a second, but let me go ahead and write this. Because the 25 is not changing, but this 9 is. Sorry, I don't know why I wrote cosine. I do know why I wrote cosine, but that's not right. Of x over 25. All right, because as this ladder is being pulled away, this angle is changing, but the ladder is not, if that makes sense. So maybe what would be best to do first is figure out what theta is equal to, and that you could use their inverse. You actually don't need this, but you can go ahead and do this. Is the inverse cosine of that. And the reason why I'm saying you don't actually need this is there's a way around it. So what's going to happen is when I then ask you for the derivative of sine, that is cosine of theta times d theta dt, is equal to the derivative of this is 1/25 times dx dt. Well, I'm going to solve for d theta dt, and that's where I'm going to plug in 1/25 times 2, because that's what dx dt is. Remember we wrote that down earlier. Divided by, to get cosine over, you have to divide it. Well, what is cosine of theta? Well, theta is equal to this piece. So what you could do, since you're allowed a calculator, is figure out what second sine of 9/25 is. And then you can do cosine of that answer, right? Inverse sine of 9/25, and then cosine of that answer. Make sure you're in radians too. I almost forgot to double check that. And then in the numerator, you have 2/25 divided by that answer. 2/25. Let's just do that. And then divided by that answer. And you get that that's increasing by about 0.086 radians per second. By the way, if you ever change that to degrees per second, you're technically right. But you can just, in calculus, we stick with radians. So with the calculator, I shared with you that answer. I just want to point out that you don't actually need a calculator, because with the rule of if you did the inverse sine, that would find you the angle measure. Well, if you're doing the cosine of that angle, then you can figure out what they use different variables, so I need to be careful with how I say it. But if you did the Pythagorean theorem, you'd figure out the adjacent side is the square root of 544. So if you plug this into your calculator, you will get the same 0.08, whatever that number is that I came up with earlier. So again, you can pause the video if you would prefer to write this answer down. I feel like if I explained it this way, though, I would have lost a few of you. But if you follow along, then that's perfect. All right. So this problem could be seen as, like if I had students that argue how the problem is set up, if there's usually an argument over what's happening, they try to clarify it, whether it's with a picture or some other reason. So anyway, this problem is supposed to be, you have an antenna that directly overhead is 5 miles, and the plane is traveling this way. So the way this problem is set up is that the distance between the antenna and the plane, so they're inferring that dy dt is the 240. I just don't like how some of the phrases are. So then dy dt is equal to 240. And they tell you that the plane went 10 miles, so the x equals 10, but again, it's changing. So what you would want to do is use the Pythagorean theorem to figure out that y, this value, would be the square root of 125. 5 squared plus 10 squared would equal this. So you could set up your Pythagorean theorem. 5 squared, that's a constant, plus x squared is equal to y squared. So 5 is not changing. Once that happened, that happened. So the derivative of the left side would be 2x dx dt. And on the right side, it would be 2y dy dt. So as I pointed out, we know that, well, first of all, let's divide everything by 2. Get rid of that. We know that x is 10. We don't know dx dt, but we do know that y would be the square root of 125 times 240. And you could simplify that, by the way, but I would probably just leave it the way I have it. Divide the 10 over and write it as 24 root 125 miles per hour. Yeah, I would not do it that way, but that's is that the same answer? 24, because you can factor out a 5. 24 times 5 is 120 root 5. Something like that. All right. I'm trying to hurry through this so you don't have to watch a fourth video. So we have radius of a sphere. Remember, the surface area is for pi r squared area. So what's the rate that the surface area is changing? That's dA dt, and that would be 8 pi r dr dt. And so as you're looking at that, the radius is 6, so 8 pi times 6 times dr dt is 2. They tell you that in the directions. So 12 times 8 is 96 pi inches squared per minute. And again, I don't really want to make you watch a whole other video, so I'm going to jump to the last one just to get you to the final answer. You can pause the video, try it on your own, and look back and see if you get the same answer. There's going to be some hiccups in this unit. That's why we're spending a couple days and we're doing a lot of problems. And I'm going to stop the video. And make sure you try things on your own before coming to class and asking good questions. Good specific questions get good specific answers.